Hello, this is a little tutorial on how to translate one function to another function. Um, so as a basis, just so we know where we are, we've got two functions graphing here. We've got this red one, which is the first one up here. We've got the blue one, which is the second one right here. Okay, I can just turn this off right here and we'll focus on the red one. So the red one has a base function, I call it a base function, of x squared, meaning it's this x squared base function that is translated over here. To show you that, what we're going to do is we're going to take just a regular function, x, we'll put it in parentheses just for fun, x squared, okay? This is your standard x squared function. Now, all I have to do is undergo a couple of translations and I can overlay this function on this function here. How do I do that? Well, the first thing I'm going to want to do is just shift it 3. Well, actually, the first thing I do is just multiply by -1. That will shift the direction. Okay, so -1, that shifts it down. Then I'm going to shift it over 3. Well, yeah, let's shift it over 3. To do that, we're going to add 3, so that puts it over there. And then I need to move it up 1, so I just put a +1 out here. Oop, that's 12, doesn't work. And the last thing I want to do is I want to open it up. So you see the inner one is just too narrow. To open it up, I need to put in a number less than 1. Well, up here we have 1/2, so we're going to put in 1/2. Voila, I just translated the x squared into this function right here by going through these translation steps. I made it negative, which flipped it. I then translated it over here to 3, moved it up 1, and then I changed the coefficient here in order to open it up and overlay it perfectly. Okay, so that's how we would translate from a base function to this function. All right, I think most people understand that. But what we're going to learn now is how to translate this function to make this function. How do I translate this curve to become this curve? And that's what we're going to discuss here. So to do that, we're going to go through a couple of steps. So we're going to take this function right here, I'm going to copy it, I'm going to paste it down here, voila, we got the new function. It's now a different color blue. Can I change the colors? I don't like that blue. Yeah, don't know how to change colors. But anyways, so we got this dark blue, and what I'm going to do is instead of, I'm going to shift it, I'm going to take this x plus 3 over here, and I'm going to shift it 9 this way. If I shift it 9 that way, I should put it back over here on 6. So to do that, what I'm going to do is I'm going to subtract 9. Okay, voila, I just move that over here. The next thing I'm going to do is I'm going to move this up here to 2 more. So I'm going to go ahead and add +2. Oh, so I got that. The next thing I'm going to do is I'm going to multiply it by this function right here. I'm going to multiply this whole thing right here by, so I ended up with 2, positive 2, but I started with 1/2. Well, how do I go from -1/2 to 2? Well, I can multiply it by -4. If I multiply -1/2 by -4, that gives me, voila. So the negative, by multiplying it by that negative, put it back up, and multiplying it by the 4 made sure it had the same width as what we had here. So you see here is, you see the remnants of my original equation, the x plus 3, the -1/2, and the 1. And what you see here is our new equation, where we take that, we multiply everything here by 4, we subtract the 9 on the inside, and we put a 2. To put this another way, let's bring up a little spreadsheet. So here's kind of the same idea, except we're looking at it, the actual numbers, the actual coordinates, instead of graphing it. So here's f of x. This is the exact same function as you see up here. Oop, I lost it. Let's go back. It's instead of -1/2, we have -0.05, which is the same thing, times x plus 3, and then this caret means raised to a power of 2, which is squared. and then we have plus 1. Okay, so if I look at these numbers here, these points, these x points, -5, -4, -3, -2, -1, and I apply, this is the Excel formula if you wanted to look at it, but it's exactly executing this. I'm multiplying -0.05 times this value plus 3 raised to the second power plus 1. Okay, and then this gives me the y value. So I have x, y value pairs. Here's my point, -5, -1, -4, 0.5, -3, 1. Which when you look on here, here it is, -5, -1, -4, 0.5, -3, 1. So this is perfectly calculated to figure out those points. Now g of x is right here. That's the second formula here. Notice it's 2 times, in parentheses, x minus 6, quantity squared, plus 3. So that is that function there. And here are these points. So here's the points 4, 5, 6, 7, and 8. Okay, which is these points right over here. Okay, and notice that when we plug in the formula, and you can kind of see here's the formula, 2 times the x value minus 6, quantity squared plus 3, we get the y. So the y ends up with, when x is 4, y is 11. So that puts us way up here. In fact, I'd have to bring this down a little bit. Here's 11. So if I click right here, you should see 411. Yeah, real close to 4, almost 4. Come on, there we go. 411, got it. Okay, so that just proves that that point exists on the line. So 411, 5, 5. Okay, so 5 goes up to 5. To show that, where's 5? There's 5. So there's 5, 5 right there. There's that point. 6, 3. 6, 3 is at the bottom, the minimum. 7, 5 goes right up to here. And 8, 11 goes all the way up to here. So these are this is the proper this is the proper calculation for g of x. Okay? Now the question is there any way that I can use f of x, use this formula, and use those translation factors for this formula to get the same as this formula? And that's what this is here. Notice that g of x is equal to -4 times f of x minus 9 plus 2. That should look very familiar to you. It's kind of what we had right up here. Here's that -4 times, and then here's f of x, and then here's that minus 9. Now we're going to, the f of x, x plus 3 was part of the original, so we have to keep that. And then you have the minus 9. And then here's the plus 1 from f of x, and then we added the 2, just like we did here. So it's a different way of writing it, but this is what it looks like when you calculate it. How you calculate it here is the following, and it's very similar to what we have here. What I'm doing is I'm taking -4 times the original -0.05 times the x value plus 3 minus 9, okay, squared, plus that 1 in the original f of x plus the 2. Voila, it calculates the y. So I put in these same x values that I have over here, and using this new formula, which is different from this formula. See, this is the original g of x, but this is the transformed, this is the original g of x, but this is the transformed f of x, which is equal to g of x. That's what this is. This is the transformed f of x that now equals g of x. Okay? And notice it is equal because it gives me the exact same points. Because I have the exact same points, I know that this transformation works. Okay? And then the question is, well, how can I use this transformation to calculate the points? Well, this is exactly how. You can use the formula like this, or what we can do is we can break it apart in sections. Now, here's what I did. So, here's the original f of x. I got my original same 5 numbers I had up here for x, -5 all the way to -1. And then for f of x, what we're going to do is we're going to calculate the first part we're going to calculate is the x plus 3 quantity squared. That's this YA. So when I calculate that, it's just the x value right here plus 3 quantity squared. Okay. What do I get? I get this value right here, 41010. Okay. Then I'm going to multiply this number by the -0.05. Because remember, see I multiplied that? And then I get this number here. Okay. The last part of this is I'm going to add that 1. So then I take this number, add 1, and I get this number. Okay. So this is my final number. Now notice that this final number is exactly the same final number here. So I just broke this whole process into steps. That's all I did. So these are the kind of the intermediary steps. Now over here I did the exact same thing for g of x. Here's the x, and here's the inner part where we take that, you know, x minus 6 quantity squared, and then I multiply it by the 2 in the front right here, and then I add the 3 right here. Voila, I get the same final numbers. Well, when you're doing this type of breaking it apart, and you're doing that for a transformation of a function, which is what we have here, you do it the same way. So here are my x values that are same as here. By the way, these x values are the original x values plus 9. Because remember, we shifted it over 9, so we added 9 to the x. So to do that, I just basically take this value, add 9, and I get this value. Okay. Then y of a here, this first step, is I take the formula x plus 3, which is the original f of x formula, minus the 9, and then quantity square that. And that's what I did right here. So see, I notice I got that x value plus the 3 minus the 9, quantity squared. Okay? And so that gives you this step here. And then the next part is I take the original f of x, which has the -0.05 times this, and then I multiply that by the -4 here. So that's what that is, the -4 times the original f of x of -0.1/2 times that YA value. It gives me this number. And then finally, I take the original, I take this number, add the 1 to it from the f of x, and then I add another 2. And that gives me this final number. So in the end, this final number equals this, which equals this graph over here. So I get the 4, 11 pair, 5, 5, 6, 3, 7, 5 pairings, okay? So when you're trying to calculate the x and the y values, this is how you would go about it. You can break it apart, and I would suggest breaking it apart into its sections. And to do that, in each part, you do the f of x original, you know, the x plus 3 here, and then you do the shift that you need for the transformation function. So the x plus 3 minus that 9, and you calculate, okay? And then for the coefficient, or the outer coefficient, which was -0.5, you keep that, so -0.5 times this, but then you multiply it by this transformation coefficient. Voila. Okay. Lastly, you take this shift, which is upwards, shift of 2. You take the original shift of 1, you keep that right here, and then you add the new transformation shift of 2, and that will give you the final y values for these x values that will match this g of x. In short, g of x, taking this formula and transforming it to this formula, this is a new formula altogether, this is the new formula, this is the old formula. To go from here to here, I undergo a translation, and this is the translation, and in the format of how we write that translation is I take and I subtract 9 from the original f of x. I multiply the coefficient by -4 from the original f of x. And then I add 2 from the original shift upwards of the original f of x. And that will get us the final values. So there you go. That's how you calculate points through a transformation of from one formula or from one function to another function. Okay. I hope that helps. Any questions, let me know.